Hello, in this lecture, you are going to learn how to disable what is called recursive query on the DNS server.
Here's an example of a recursive and an iterative query. A DNS resolver labeled R is indicated from the PC. The user has typed in the hostname gopro.com into their computer's browser. The browser checks the local cache, number 1, to see if the IP address of gopro.com is in the computer's cache memory. It is not. The resolver sends a recursive query, number 2, for the IP address of gopro.com to the ISP's or service provider's DNS server. The ISP's DNS server looks up the address of gopro.com in its cache and does not find it. If it would have found it, it would have returned the query back to the PC and the transaction would have been completed. The ISP's DNS resolver, marked with an R, sends an iterative query, number 3, to the root hints servers. Every DNS server has a root hints file. This file contains the host names and IP addresses of the root servers on the Internet. An iterative query is different from a recursive query. An iterative query works like this. If the DNS server does not know the answer but has information that will help resolve the query, it will respond back with this information. The root hint server knows nothing about gopro.com, but it does know about the next level in the DNS hierarchy, the .coms, or TLD, which is top-level domains. So the root server sends a referral back to the ISP's resolver pointing to .com. Now that the ISP's resolver knows about .com, the ISP DNS resolver sends a new iterative query, number 4, to the .com asking what is the IP address of gopro.com. The com servers won't have the IP address for gopro.com, but will know the authoritative name servers for gopro.com. Using this information, the ISP DNS server will send a final iterative query, number 5, to the DNS authoritative name servers at gopro.com and obtain the IP address for gopro.com. The PC's browser receives its answer to its recursive query and places the information into its cache and initiates an HTTP session to the IP address of gopro.com. The whole process took 4 queries. Number 1, a recursive query from the desktop PC resolver to the ISP. Number 2, an iterative query from the ISP to the root hint servers. Number 3, an iterative query from the ISP to the .com servers. Number 4, an iterative query from the ISP to the authoritative DNS servers at gopro.com. This may seem like a lot of queries for one address, but once the process has been completed, each step of the process is now stored in the server's cache. If the PC user typed Microsoft.com into his browser to his local DNS server, the .com would already be stored in his ISP's local cache. The ISP does not need to contact the root hint server again. This time, the ISP server would contact the .com server to obtain the authoritative servers for Microsoft.com. Things to note. Root servers will only accept iterative queries. In other words, they will only pass on the best information or a referral. Root servers must be available at all times, so root servers do not contact other servers for an answer to obtain a result. This is why caching is used in every step of the process to reduce the time of these queries. How to display a computer's resolver cache memory. The display DNS command displays the current resolver cache before the recursive query. To do this, open a command prompt, type in ipconfig /display DNS. The resolver cache is displayed. Open your computer's internet browser. Type google.com. Reopen a command prompt. Type ipconfig /display DNS. Note the difference. More records have been added.
Great job getting through this lecture. We will see you in the next lecture.